Hi, everybody. It's Miss Rose. We have one last thing to learn about trigonometry. You know now about sine, cosine, and tangent, but what do these crazy little negative ones mean? So that's what we're going to learn. It has something to do with this vocabulary word, inverse. So let's check out the first problem and see what we're trying to do. This doesn't look that different from the trigonometry problems that we've been doing, although I see that one major difference is you're not given an angle measure, you're given this little symbol here instead. That's the Greek letter theta. In upper level math, you'll see a lot of the times, sometimes when I mark a diagram, people will say, oh, is that X supposed to be for the angle or is that X supposed to be for the side? So you'll see as you get into upper level math, a lot of times Greek letters are used for angles. And then regular letters like X, Y, and Z are used for side lengths. So it's this problem, I guess the main difference between what you're asked for in this one and what we were doing earlier in the unit is I was giving you an angle and asking you for side lengths. Now I'm giving you side lengths and I'm asking you for an angle. So let's look at this theta. Let's put an arc on that angle. And let's label which sides we have. Do we have the hypotenuse? Yes, that's the 25. I'm going to label it H. Then do we have the opposite leg? No, we have the adjacent leg instead. So I'm going to write down my SOHCAHTOA. Some old hippie caught another hippie tripping over apples. And let's see what we have. We have A and we have H. Which one is that? Think for a second. Is it going to be sine, cosine, or tangent? It's going to be cosine. So that's the one that we're going to use. So we're going to set it up just like what we learned before. Cosine of the angle, this time that angle is theta, equals A over H, 21 over 25. So when you go to type this in your calculator, you might realize that you can't type cosine of theta. You need to be able to type cosine of some angle measure. So don't you kind of wish that the 21 over 25 was our input and that the theta was the output because we can't just type theta in the calculator? Well, that's what an inverse is. An inverse allows you to switch the input and the output so that the 21 over 25 can be the input and the theta can be the output. We'll do a little switcheroo. But when you do that, you can't just use regular cosine. You have to use inverse cosine. So what's cool about these problems, though, is really once you do the setup and you take the inverse, all you do is type that into the calculator and the calculator magically will give you the answer. So let me show you on the Desmos calculator what that looks like. So normally on a regular calculator, you'll hit second cosine. On this one, I had to go to function and then inverse cosine of 21 over 25. I couldn't remember the numbers. 21 over, oh, that is not what I meant to type in. It needs to be in my parentheses. 21 over 25. And then I could close the parentheses. I don't even need to, but this here is my angle measure. It comes out to be a messy decimal. I usually like about 3 decimal places, 32.859, but then I'd have to round up. So 32.86 is probably the best estimate. 32.86 degrees is approximately the measure of that angle theta. All right, let's try another similar example. So first thing I'm going to do, some old hippie caught another hippie tripping over apples. Then I'm going to put an arc on my theta. Am I given the hypotenuse? Yes. Am I given the opposite? Yes. We've got opposite. We've got hypotenuse. Take a second to decide which one it should be. You want to use sine, and that's really the hard part. After that, it's just going to be the calculator. Sine of theta is 9.5 over 11. I want to switch my input and my output, so I have to use this new inverse. Switch the input and the output. Type it in the calculator, and ta-da, that will give the answer. So this time, I'm going to do under function again, sine inverse was 9.5 over 11. So 59.727 degrees approximately. It's always going to come out messy unless it's one of our special 45 or 30 or 60 degree angles. What was it again? 59.727. Degrees is our theta. All right, let's see what we've got next. We've got a word problem, but it's still going to be the same type of problem. A worm, there it is 14 feet away from the base of a tree. It's my beautiful drawing. Base of the tree, worm, 14 feet apart. That's where my 14 goes. It sees a bird 23 feet up in the tree. 23 feet high. At what angle of elevation does the worm see the bird? So an angle of elevation is the angle at which the worm is looking up at the bird. So I'll call it theta so that it'll look like our previous problems. Okay, some old hippie caught another hippie tripping over apples. Let's set up our trig equation. Are we given the hypotenuse? No. Are we given the opposite leg? Yes. Are we given the adjacent leg? Yes. So take a second and decide which one that's going to be. Opposite, adjacent. It's going to be, ding, 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 tangent. Tangent of what? The angle, theta, equals O over A, 23 over 14. All right, I don't want theta as my input. I want 23 over 14. So when I switch the input and the output, I need to do the inverse. And then I just go over to the calculator. This time it is tangent inverse. I keep forgetting the numbers, 23 over 14. 23 over 14, 58.671-ish degrees. Does that sound reasonable? Well, 23 is bigger than 14. If it was a 45, 45, 90, it would be isosceles. 14, 14 or 23, 23. So since 23 is the bigger side, it goes across from the bigger angle. So it does make sense because the angle should be bigger than 45 degrees. Just as a little side note, you might have noticed this time the bigger number was on top. For the previous two problems, the smaller number was on top. This kind of matters because the hypotenuse is always the biggest side. So if you were doing inverse sine and you accidentally did 23 over 14, your calculator would be like, nope, error. Can't have a hypotenuse that's smaller than one of the legs. So just a little side note on that. All right, here's the last problem. Take a look at it and see what's wrong with this one. We are doing right triangle trig. This is not a right triangle. So we have to make a right triangle. There it is now. And I want angle B. I could call it theta if I want, or I could call it B. And then one thing I have to be careful of is I'm not using the 18 anymore. I split that side in half into 9 and 9. So this is really the right triangle that I'm using. I actually recognize 9 and 41 as a triple, so I think I even know what the height of the triangle is, but that's not what we're asked for. We're asked for the measure of angle B. So I'm going to write down my SOHCAHTOA. Some old hippie caught another hippie tripping over apples. Let's take a look at where theta is and which sides we know. So do we know the hypotenuse? Yes. Do we know the opposite leg? No. So we must know the adjacent leg. Adjacent, hypotenuse, which one is it? A over H is cosine. Cosine theta equals A over H. I want my 9 over 41 to be my input. I want my theta to be my output. So I do the inverse. I go back to the calculator and I go cosine inverse 9 over 41. 77.319, but I want to round it up. So 77.32 would be the best estimate for that one. 77.32 degrees is approximately equal to theta. That seems like a pretty big angle, but this is a pretty big side. It's a 940-41 triangle. 40 is a big side. It goes across from a big angle, so I'm not surprised that it is 77.32 degrees. That's your little summary on how to use trig to find angles and what an inverse is. Let me know if you have any questions. Bye.